Dear students, in this video I will explain solutions of the state equations and problems on solutions of the state equations. Initially, the solutions of state equations formulas are required. For that, consider the state equation of linear time invariant system as x dot of t is equal to a into x of t plus b into u of t. This state equation can be a two types, that are first one is homogeneous, second one is non-homogeneous. What is the homogeneous equation and what is the non-homogeneous equation? First one, homogeneous equation. The equation is like this. Then the equation state equation is called as homogeneous equation. That means x dot of t is equal to a into x of t. There is no b matrix and u of t term. Then this equation is called as homogeneous equation. So solutions of the homogeneous equations are, that is x dot of t is equal to e power at into x of 0. This is the formula for calculating the solutions of state equation when the equation is homogeneous. Non-homogeneous equation. The non-homogeneous equations are like this. X dot of t is equal to a into x of t plus b into u of t. A matrix is there and B matrix also is there. So equation is like this, then the equation is called as non-homogeneous equation. If the equation is x dot of t is equal to a into x of t only, then the equation is called as homogeneous equation. X dot of t is equal to a into x of t plus b into u of t is nothing but non-homogeneous equation. Now the solutions of the non-homogeneous equation. We want to calculate the solutions of the non-homogeneous equation. We can calculate the two terms. One is ZIR, second one is ZSR. That is x of t is equal to e power a of t into x dot of x of 0 plus integral 0 to t into e power a t minus tau into b of u of tau d tau, where this term is called as ZIR and second term is called as ZSR. Therefore, the solutions of the non-homogeneous equation x of t is equal to ZIR plus ZSR, where ZIR is nothing but 0 input response, ZSR is nothing but 0 state response. So this is the formula for calculating the solutions of non-homogeneous equation. But in this equation, integrations will be there from 0 to t, so that it is difficult to calculate the solutions of the non-homogeneous equation. To reduce this complexity, we go for the method that is Laplace transform method. That is nothing but solutions of the non-homogeneous equation by the Laplace transform method. That is x of t is equal to L inverse of x of s into x of 0 plus L inverse of x of s into b into u of s. This is the equation for calculating the solutions of the non-homogeneous equation by Laplace transform method. So finally, we can calculate the phi of s and apply the inverse Laplace transform, and the answer multiplied with x of 0, this term completed, and x of s multiplied with b and multiplied with u of s, and final answer apply the inverse Laplace transform, this term also completed. So here the problem is pi of s. How can you calculate this pi of s? The formula for calculating the pi of s is pi of s is equal to si minus a whole power minus 1. That is the meaning of pi of s. Already we know si minus a whole power minus 1 formula, that is adjoint of si minus a by mod si minus a. We know how can you calculate the adjoint of si minus a and mod si minus a. Therefore, this pi of s is in s domain. If you want to convert this s domain into the time domain, apply the inverse Laplace transform to the pi of s. Therefore, inverse Laplace transform of pi of s is equal to pi of t. Simply can be write as pi of t, that is nothing but e power at. Already we know e power at, pi of t is equal to e power at is nothing but state transmission matrix. So this is the formula for calculating solutions of the non-homogeneous equation by Laplace transform method. So this is the final formula. In this formula, pi of s is equal to, this is the formula, si minus a whole power minus 1 is equal to adjoint of si minus a by mod si minus a. So by using these formulas, we can calculate the solutions of the homogeneous as well as non-homogeneous equations. Now consider the example for the non-homogeneous equations. Example, given x of t is equal to 0, 1, minus 2, minus 3 into x1 of t into x2 of t plus 0, 1 into u of t. Find the unit step response when x of 0 is equal to 1, 1. So this is the given problem. Find out the solutions of this problem. We want to find out the solutions of this problem. Initially, we identified the given problem is either homogeneous or non-homogeneous. If the given problem having A matrix and B matrix, then the given problem is non-homogeneous problem. If only A matrix is there, then the problem is non-homogeneous. If both A and B are having the given problem, that is nothing but non-homogeneous equation. So this one is non-homogeneous equation. Why? Because matrix A and matrix B both will be there, so that this given problem is non-homogeneous equation. Therefore, now we would like to find out the solution for this problem. First, write down the given values. A is equal to 0, 1, minus 2, minus 3, B 0, 1, and x of 0 is equal to 1, 1. So output y of t is equal to, so adding of these two, ZIR plus ZSR, 0 input response and 0 state response. So initially we calculate ZIR, after that we calculate ZSR, combined with these two we can get y of t value. So initially we can calculate ZIR. ZIR is equal to e power at into x of 0. That is equal to e power at means, so ZSR means that is equal to L inverse of pi of s multiplied with b multiplied with u of s. So combine, calculating these two and finally combine these two values, we can get y of t. So e power at, initially we calculate e power at and multiplied with x of 0, ZIR completed, and pi of s multiplied with b and multiplied with u of s, apply the inverse Laplace transform, then ZSR is completed. Now we want to calculate ZIR. ZIR is equal to e power at into x of 0. E power at is nothing but inverse Laplace transform of pi of s. So that is e power at. E power at is equal to L inverse of pi of s. We know pi of s is equal to formula, that is Si minus a whole power minus 1. That means adjoint of Si minus a by mod Si minus a. So initially we would like to calculate Si minus a. After that, adjoint of Si minus a mod Si minus a. Then we can calculate the pi of s and apply the inverse Laplace transform. We can get e power at, and this e power at multiplied with x of 0. X of 0 is given in the given problem. Then ZIR completed. So initially we would calculate Si minus a value. Si minus a is equal to A matrix of order 2 by 2. So that identity matrix I order also 2 by 2. S into 1 0 0 1 multiplied with these two and subtract this matrix, we get S minus 1 2 S plus 3. Now adjoint of Si minus a is equal to D minus D minus C A. This value is D, this one is minus D, this one is minus C, this one is A. So that is nothing but adjoint of Si minus A. Mod Si minus A. Mod Si minus A is nothing but AD minus BC. That is nothing but AD S into S plus 3 minus of minus 1 into 2. That is equal to S square plus 3S plus 2. That is equal to S plus 1 into S plus 2. This is mod Si minus A value. Therefore, Si minus a whole power minus 1 is equal to adjoint of Si minus a by mod Si minus a, that is equal to S plus 3 by S plus 1 into S plus 2, 1 by S plus 1 into S plus 2, minus 2 by S plus 1 into S plus 2, S by S plus 1 into S plus 2, because adjoint of Si minus a is this one, S plus 3, 1 minus 2 minus S. Therefore, Si minus a whole power minus 1 is nothing but this one. That is equal to pi of s value. Pi of, therefore pi of s is equal to, so this one here, this pi of s value is in normal form. Now we want to apply the inverse Laplace transform. For that, we can apply the partial fractions. Therefore, pi of s is equal to 2 by s plus 1 minus 1 by s plus 2. After applying the partial fractions, this term s plus 3 by s plus 1 into s plus 1 s plus 2 can be converted is like this, and this 1 by s plus 1 into s plus 2 can be converted into like this, and this minus 2 by s plus 1 into s plus 2 can be converted into like this, and s by s plus 1 into s plus 2 can be converted into like this after applying the partial fractions. So now this is pi of s value. We want e power at. E power at is equal to L inverse of pi of s. Pi of s value is this one. Apply the inverse Laplace transform for this one. So apply each and every element, inverse Laplace transform for each and every element. So apply 2 by s plus 1 minus 1 by s plus 2. So 2 is the constant, 2 into 1, 2 into 1 by s plus 1. So 1 by s plus a format, that is 2 into e power minus t minus 2 1 into e power minus 2t, and 1 by s plus 1 minus 1 by s plus 2, 1 by s plus a format e power minus t minus again 1 by s plus a format e power minus 2t. So apply like this, we can get the final answer. E power at is equal to L inverse of pi of s is equal to this one. So this value multiplied with x of 0, then we can get ZIR. Therefore, ZIR is equal to e power at multiplied with x of 0. So e power at multiplied with x of 0. X of 0 is column matrix of 1, 1. So this value is given a problem. Therefore, multiplied with e power at with 1, 1. So the final answer is this one. So again, simplified this one, we can get final answer is this one for ZIR. So up to now ZIR completed. Now we want to calculate ZSR. Therefore, ZSR is equal to L inverse of pi of s multiplied with D multiplied with U of s, where U of s is already given clue, that is U of s is equal to 1 by s due to unit step input. So in the problem already given input is unit step, so that U of s is equal to 1 by s. Now we can apply inverse Laplace transform for pi of s multiplied with b multiplied with u of s. That is equal to L inverse of pi of s value is this one multiplied with b value is this one multiplied with u of s value is 1 by s. Multiplying this value, matrix multiplication, multiply these two matrix, and final answer multiplied with 1 by s. Therefore, if we multiplying all these values, we can get L inverse of 1 by s into s plus 1 into s plus 2, 1 by s plus 1 into s plus 2. Applying the inverse Laplace transform. These two values are not in direct form, so that again apply the partial fractions for this one and this one. Therefore, we can get L inverse of, after applying the partial fractions, this term can be converted as 0.5 by s minus 1 by s plus 1 plus 0.5 by s plus 2. And this term can be converted as 1 by s plus 1 minus 1 by s plus 2. Now applying the inverse Laplace transform, these two terms are in standard format. Therefore, 0.5 into e power minus t plus 0.5 into e power minus 2t, and apply the inverse Laplace transform for this term, that is e power minus t minus e power minus 2t. So this is ZSR value. Finally, we want to calculate the output response. Y of t is equal to ZIR plus ZSR. So substituting these two values, this value is ZIR and this value is ZSR. So adding these two values, finally we can get, this is the